Question 1. Research into the implementation of Identity and Access Management (IAM) within an Oracle Cloud Infrastructure (OSI) tenancy for a rapidly growing software development company reveals a need to balance developer productivity with stringent security controls. The company's security and compliance team is evaluating different strategies for granting access to OCI resources. Which of the following approaches best aligns with OCI's IAM best practices, specifically focusing on implementing least privilege, role-based access control (RBAC), and multi-factor authentication (MFA? Option A. Create custom IAM groups for different development teams e.g. front-end, back-end, DevOps. Assign granular IAM policies to these groups that grant only the necessary permissions for their specific tasks within their project's compartment, and enforce MFA for all users accessing the OCI console or using OCI CLI/APIs. Option B. Grant all developers full administrative privileges within the OCI tenancy to ensure they have unrestricted access to all resources, simplifying their workflow and eliminating the need for complex permission management. Option C. Assign individual, highly specific IAM policies directly to each developer for every OCI resource they might interact with, and implement MFA only for the security administrator account. Option D. Establish a single, broad IAM group for all development personnel. Assign them read-only access to all OCI resources, and require MFA for all users. The correct answer is A. Create custom IAM groups for different development teams, e.g. front-end, back-end, DevOps. Assign granular IAM policies to these groups that grant only the necessary permissions for their specific tasks within their project's compartment, and enforce MFA for all users accessing the OCI console or using OCI CLI/APIs. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments, balancing operational efficiency with robust security. The primary challenge lies in granting necessary access to development teams for rapid iteration while preventing unauthorized access or accidental data exposure. The need to comply with Oracle Cloud Infrastructure's OSI IAM best practices, specifically least privilege, RBAC, and MFA, adds a layer of complexity. Failure to implement these correctly can lead to security breaches, compliance violations, and operational disruptions. Correct approach analysis. Implementing a granular RBAC model where each user or group is assigned specific policies that grant only the permissions required for their defined roles is the most effective approach. This adheres to the principle of least privilege. For instance, a developer might need read and write access to specific compute instances and object storage buckets within their project, but not administrative access to the entire OCI tenancy or sensitive database instances. Enforcing MFA for all users, especially those with privileged access, adds a critical layer of security by requiring a second form of verification beyond a password, significantly reducing the risk of account compromise. This approach aligns directly with OCI's IAM best practices and general cloud security principles, aiming to minimize the attack surface and ensure accountability. Incorrect approaches analysis. Granting broad administrative privileges to all members of the development team, even with the intention of simplifying access, is a significant security and regulatory failure. This violates the principle of least privilege, exposing the OCI tenancy to a much higher risk of unauthorized changes, data deletion, or accidental misconfigurations. It also makes it difficult to audit specific actions, as many users would share the same broad permissions. Assigning individual, highly specific permissions to each developer without leveraging OCI's IAM groups and roles is inefficient and prone to errors. While it might technically adhere to least privilege, it becomes unmanageable as the team grows or roles change. This lack of abstraction makes policy management cumbersome and increases the likelihood of misconfigurations or missed updates, potentially leading to security gaps or operational issues. It also hinders effective RBAC implementation. Implementing MFA only for administrative users while leaving regular users with only password-based authentication creates a security imbalance. While privileged accounts are a prime target, compromised regular user accounts can still be used to gain initial access, escalate privileges, or exfiltrate data. This approach does not fully embrace the security benefits of MFA across the user base, leaving a significant vulnerability. Professional reasoning. professionals should adopt a systematic approach to IAM. First, clearly define roles and responsibilities within the organization and for specific projects. Second, map these roles to the minimum set of permissions required to perform their duties, adhering to the principle of least privilege. Third, leverage OCI's IAM features, such as groups, dynamic groups, and custom IAM policies, to implement RBAC effectively. Fourth, mandate MFA for all users, with a particular emphasis on privileged accounts. Finally, regularly review and audit IAM policies and user access to ensure ongoing compliance and security posture. This structured approach ensures that security is integrated from the outset and maintained throughout the lifecycle of cloud resources. Question 2. Risk assessment procedures indicate that a new customer-facing financial analytics service on Oracle Cloud infrastructure must be launched within 3 months to capture a critical market window. The service needs to handle unpredictable user traffic spikes and ensure continuous availability of sensitive financial data, while also adhering to strict U.S. financial data privacy regulations. Which architectural approach best balances these competing demands for elasticity, scalability, high availability, fault tolerance, and cost optimization? Option A. Design the core service using OCI compute instances with manual scaling configured based on anticipated peak loads. Deploy all resources within a single availability domain for simplicity, and implement basic firewall rules. Option B. Deploy the service on a single, large OCI compute instance to minimize initial setup complexity and cost, and rely on application-level caching for performance. Option C. Architect the service using OCI Container Engine for Kubernetes OAK, with horizontal pod autoscaler configured for automatic scaling. Deploy critical components across multiple availability domains with OCI load balancers for traffic distribution, and leverage OCI block volume replication for data redundancy. Option D. Prioritize rapid deployment by using a single OCI region with minimal redundancy, and defer detailed security hardening and compliance checks until after the initial launch. The correct answer is A. Design the core service using OCI compute instances with manual scaling configured based on anticipated peak loads. Deploy all resources within a single availability domain for simplicity, and implement basic firewall rules. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for rapid deployment and innovation with robust security and compliance requirements. The organization is under pressure to launch a new service quickly, which can lead to shortcuts in design and implementation. The challenge lies in ensuring that the chosen architecture, while meeting business demands, also adheres to the Oracle Cloud infrastructure, OCI best practices, and the specific regulatory framework relevant to the exam's jurisdiction, which for this exam is assumed to be U.S. federal regulations concerning data privacy and security, e.g., HIPAA, NIST guidelines. Failure to do so can result in significant financial penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach prioritizes a layered security and resilience strategy from the outset, aligning with OCI's shared responsibility model and U.S. regulatory mandates. This involves designing for elasticity and scalability using OCI's native services like compute auto-scaling and load balancing, ensuring high availability through multi-region or multi-AD deployments with OCI load balancing and OCI block volume replication, and implementing fault tolerance with OCI availability domains and fault domains. Cost optimization is achieved by right-sizing resources, leveraging OCI's cost management tools, and utilizing reserved instances or savings plans where appropriate. This approach directly addresses the core cloud architecture principles and ensures compliance with relevant U.S. regulations by building security and resilience into the foundation, rather than attempting to bolt it on later. This proactive stance is crucial for meeting regulatory obligations like data protection and availability requirements mandated by frameworks such as HIPAA for healthcare data. Incorrect approaches analysis. An approach that focuses solely on rapid deployment without incorporating elasticity and scalability mechanisms would fail to meet the demands of a growing user base and could lead to performance degradation, violating the principle of providing a reliable service. This also creates a compliance risk, as many regulations require a certain level of service availability and performance. An approach that neglects fault tolerance and high availability by deploying resources in a single availability domain without redundancy would be highly susceptible to single points of failure. This directly contravenes regulatory requirements for data integrity and service continuity, particularly for sensitive data. An approach that prioritizes cost savings by over-provisioning resources or neglecting to implement auto-scaling would lead to inefficient resource utilization and higher operational costs, failing the cost optimization principle. While not a direct regulatory violation in itself, it can indirectly impact the ability to invest in necessary security and compliance measures. Furthermore, an approach that delays security and compliance consideration until after deployment creates significant ethical and regulatory risks. It is far more difficult and costly to retroactively implement security controls and achieve compliance than to build them in from the start. This can lead to vulnerabilities that expose sensitive data, a direct violation of data privacy regulations. Professional reasoning. Professionals must adopt a security and compliance by design mindset. This involves understanding the business requirements, the OCI service offerings, and the applicable regulatory landscape. The decision-making process should involve 1. Identifying critical business functions and data sensitivity. 2. Mapping these requirements to OCI services that inherently support elasticity, scalability, high availability, and fault tolerance. 3. Integrating security controls and compliance checks at every stage of the architecture design and deployment lifecycle. 4. Continuously monitoring and optimizing for cost and performance. 5. Regularly reviewing and updating the architecture to adapt to evolving threats and regulatory changes. Question 3. Quality control measures reveal that a financial services firm is rapidly migrating its customer-facing applications to a public cloud environment to leverage perceived cost efficiencies and faster deployment cycles. However, the internal audit team has flagged potential gaps in the firm's understanding of the shared responsibility model and the implications of different cloud service and deployment models on data security and regulatory compliance. The firm's IT leadership is pushing for immediate completion of the migration, citing competitive pressures. As a cloud architect, what is the most prudent approach to address these concerns while still aiming to meet business objectives? Option A. Proceed with the migration as planned, focusing on implementing basic security controls provided by the cloud vendor and address any compliance issues that arise post-migration. Option B. Prioritize the migration of non-sensitive applications first, assuming that sensitive data will be addressed in a later phase, and rely on the cloud provider's default security configurations for all workloads. Option C. Advocate for an immediate halt to the migration and a complete shift to a private cloud deployment to ensure maximum control over all aspects of the infrastructure and data. Option D. Conduct a comprehensive risk assessment that evaluates the specific security and compliance implications of the chosen public cloud service and deployment models, and develop a phased migration plan that prioritizes critical data and applications based on risk tolerance. The correct answer is D. Conduct a comprehensive risk assessment that evaluates the specific security and compliance implications of the chosen public cloud service and deployment models, and develop a phased migration plan that prioritizes critical data and applications based on risk tolerance. Explanation. Scenario analysis. The scenario presents a common challenge in cloud adoption, balancing the perceived benefits of rapid deployment and cost savings with the inherent risks associated with cloud computing. The core of the challenge lies in the potential for misinterpreting or underestimating the complexities of cloud service models and deployment models, leading to a misalignment between business objectives and technical implementation. This misalignment can manifest as security vulnerabilities, compliance gaps, and operational inefficiencies, all of which carry significant financial and reputational risks. Pressure to deliver quickly can sometimes overshadow the need for thorough risk assessment and strategic planning, making it difficult for architects to advocate for a measured, risk-informed approach. Correct approach analysis. The correct approach emphasizes a comprehensive risk assessment that considers the specific characteristics of cloud computing and the implications of different service and deployment models. This involves understanding that IaaS, PaaS, and SaaS offer varying levels of abstraction and control, each with its own security and operational considerations. Similarly, public, private, and hybrid deployments have distinct risk profiles. A robust risk assessment, aligned with industry best practices and potentially relevant regulatory guidelines, Though none are specified for this exam's jurisdiction, the principle of due diligence applies, allows for the identification of potential threats and vulnerabilities. By proactively addressing these risks, an architect can ensure that the chosen cloud strategy aligns with the organization's security posture, compliance requirements, and business objectives, thereby representing best professional practice. This proactive stance minimizes the likelihood of costly remediation efforts and reputational damage. Incorrect approaches analysis. One incorrect approach focuses solely on the immediate cost savings and speed of deployment, without a commensurate evaluation of the associated risks. This overlooks the fundamental characteristic of cloud computing that shared responsibility models, while beneficial, require a clear understanding of where the organization's security and compliance obligations begin and end. Failing to conduct a thorough risk assessment in this context can lead to security breaches, data loss, and noncompliance with potential industry standards or internal policies, representing a significant ethical and professional failure. Another incorrect approach prioritizes the adoption of a specific cloud service model, e.g., SaaS, without a deep understanding of its implications for data control and integration with existing systems. This can result in vendor lock-in, data sovereignty issues, and an inability to meet specific business requirements that necessitate greater control over the underlying infrastructure or application logic. Ethically, this approach fails to adequately protect the organization's assets and interests by not fully exploring the trade-offs inherent in different service models. A third incorrect approach involves adopting a multi-cloud strategy without a clear governance framework and risk management plan for inter-cloud interactions. While multi-cloud can offer benefits, it also introduces complexity in terms of security, data management, and operational oversight. Without a structured risk assessment that addresses these interdependencies, organizations can inadvertently create new vulnerabilities and compliance challenges, demonstrating a lack of due diligence and professional responsibility. Professional reasoning. Professionals should adopt a decision-making process that begins with a clear understanding of business requirements and objectives. This should be followed by a comprehensive evaluation of cloud computing concepts, including the characteristics, service models, and deployment models, in the context of the organization's risk appetite and regulatory environment, even if not explicitly defined for this exam. The principle of risk management is universal. A structured risk assessment, identifying potential threats, vulnerabilities, and impacts, is paramount. Based on this assessment, the most appropriate cloud strategy and implementation plan should be developed, ensuring alignment between technical solutions and business goals. Continuous monitoring and periodic re-evaluation of the cloud environment are also critical to adapt to evolving threats and business needs. Question 4. Which approach would be most appropriate for a global financial services organization deploying sensitive customer financial data on Oracle Cloud infrastructure, ensuring regulatory compliance and robust network security? Option A. Segmenting sensitive financial data into a dedicated OCI virtual cloud network, VCN, with granular ingress and egress controls enforced by network security groups, NSG, and security lists, implementing an OCI web application firewall, WAF, for web-facing applications, and managing all DNS resolution within this secure VCN. Option B. Utilizing a single OCI virtual cloud network, VCN, for all workloads, relying solely on default OCI security configurations, and disabling all firewall rules to maximize network throughput. Option C. Deploying all financial data within a single OCI virtual cloud network, VCN, with broad ingress and egress rules to facilitate easy access for all internal applications, and utilizing a public DNS service for all domain name resolution. Option D. Distributing sensitive financial data across multiple OCI regions without specific network segmentation or security controls, and using a mix of public and private DNS services without centralized management. The correct answer is C. Deploying all financial data within a single OCI virtual cloud network, VCN, with broad ingress and egress rules to facilitate easy access for all internal applications, and utilizing a public DNS service for all domain name resolution. Explanation. This scenario presents a professional challenge due to the critical need to balance robust network security with efficient data access for a global financial services organization operating within the Oracle Cloud infrastructure, OSI. The organization must adhere to stringent financial regulations, which mandate specific data residency, access control, and auditability requirements. Failure to comply can result in severe financial penalties, reputational damage, and loss of customer trust. Careful judgment is required to select a networking strategy that is both secure and performant, while also meeting regulatory obligations. The correct approach represents best professional practice because it proactively addresses regulatory compliance by segmenting sensitive financial data into a dedicated virtual cloud network, VCN, with strict ingress and egress controls. This isolation, coupled with the use of OCI network security groups, NSG, and security lists, ensures that only authorized traffic can reach the financial data. Implementing a web application firewall, WAF, further protects against common web exploits. The use of OCI DNS for internal and external resolution, managed within the compliant VCN, provides centralized control and auditability. This strategy aligns with common regulatory principles requiring data segregation, least privilege access, and robust security monitoring, which are implicitly expected in regulated industries. An incorrect approach that relies solely on default OCI networking configurations without explicit security hardening would be professionally unacceptable. This would fail to meet the implicit regulatory expectation of proactive security measures for sensitive financial data, potentially exposing it to unauthorized access. Another incorrect approach that bypasses security controls for performance reasons, such as opening broad network access to financial data VCNs, would represent a severe regulatory and ethical failure. This directly contravenes the principle of data protection and confidentiality mandated by financial regulations. Furthermore, an approach that uses unmanaged or external DNS services for critical financial data resolution, without proper integration into the OCI security posture, introduces significant risks of misconfiguration, unauthorized access, and lack of auditability, all of which are unacceptable in a regulated environment. Professionals should employ a decision-making framework that prioritizes security and compliance from the outset. This involves understanding the specific regulatory landscape applicable to the organization's industry and geographic locations. The framework should then translate these requirements into concrete OCI networking design principles, such as network segmentation, granular access control, and robust security services. Continuous monitoring and auditing of network traffic and configurations are essential components of this framework to ensure ongoing compliance and identify potential vulnerabilities. Question 5. Compliance review shows that multiple development teams within an organization are independently provisioning and managing OCI resources, leading to significant variations in security configurations, cost management practices, and adherence to internal compliance standards. The architecture team needs to implement a strategy to bring these disparate cloud practices under a unified, enforceable governance framework without significantly impeding development velocity. Which of the following approaches best addresses this challenge? Option A. Establish a Cloud Center of Excellence, CCOE, responsible for defining and enforcing standardized OCI governance policies, providing pre-approved resource templates, automation scripts for provisioning and security, and ongoing guidance to development teams. Option B. Focus solely on deploying advanced security monitoring tools in OCI to detect and alert on policy violations after resources have been provisioned, without establishing proactive governance policies or enablement programs. Option C. Mandate that each development team independently research and implement their own cloud governance policies and security best practices within OCI, with periodic audits to ensure compliance. Option D. Implement a strict, manual approval process for all OCI resource provisioning requests, requiring sign-off from security, finance, and compliance departments before any resources can be deployed. The correct answer is A. Establish a Cloud Center of Excellence, CCOE, responsible for defining and enforcing standardized OCI governance policies, providing pre-approved resource templates, automation scripts for provisioning and security, and ongoing guidance to development teams. Explanation. Scenario analysis. This scenario presents a common challenge in cloud adoption, where the rapid pace of innovation and deployment can outstrip the development and enforcement of robust governance policies. The core difficulty lies in balancing agility with control, ensuring that while teams can innovate quickly, They do so within defined security, compliance, and cost management boundaries. The professional challenge is to identify the most effective strategy for bringing disparate cloud practices under a unified, enforceable governance framework without stifling productivity or introducing new risks. This requires a deep understanding of OCI services, best practices for cloud governance, and the ability to translate organizational requirements into actionable policies. Correct approach analysis. The correct approach involves establishing a centralized cloud center of excellence, CCOE, responsible for defining and enforcing cloud governance policies. This CCOE acts as a strategic advisory and enablement function, developing standardized templates, automation scripts, and best practice guidelines for resource provisioning, security configurations, cost management, and compliance adherence across OCI. By providing these pre-approved automated solutions, the CCOE empowers development teams to deploy resources rapidly while ensuring adherence to organizational standards. This approach aligns with OCI best practices for governance, which emphasize a federated model where a central team sets the guardrails and individual teams operate within those boundaries. This promotes consistency, reduces risk, and optimizes resource utilization. Incorrect approaches analysis. One incorrect approach is to delegate all governance responsibilities to individual development teams without central oversight or standardized tooling. This leads to inconsistent security postures, potential compliance violations, uncontrolled spending, and a lack of visibility into the overall cloud environment. It fails to leverage the benefits of a unified governance framework and can result in a fragmented and risky cloud footprint. Another incorrect approach is to implement overly restrictive, manual approval processes for all cloud resource deployments. While this might seem to enhance control, it significantly hinders agility and innovation, leading to developer frustration and a potential shadow IT problem, where teams bypass official channels to meet their project timelines. This approach is antithetical to the agile nature of cloud computing and OCI's design principles. A third incorrect approach is to focus solely on technical controls without addressing the human and process elements of governance. Cloud governance is not just about configuring security policies. It also involves defining roles and responsibilities, establishing clear communication channels, and providing ongoing training. Neglecting these aspects means that even well-defined technical policies may not be effectively understood or implemented, leading to governance gaps. Professional reasoning. Professionals should approach cloud governance by first understanding the organization's specific business objectives, risk appetite, and regulatory obligations. This understanding should then inform the design of a governance framework that is both effective and enabling. A CCOE model, supported by automation and clear policies, provides the best balance between control and agility. When evaluating solutions, consider how they promote standardization, automate enforcement, and provide visibility. Always prioritize solutions that empower teams to operate within defined guardrails rather than imposing rigid, manual gatekeeping. Question 6. The analysis reveals that a financial services organization needs to deploy a critical application in Oracle Cloud infrastructure. This application requires secure, private connectivity to on-premises financial systems, controlled outbound access to external APIs for data enrichment, and secure, auditable access for external auditors. The organization must adhere to stringent data protection and financial industry compliance standards. Which networking strategy best meets these requirements while minimizing exposure to the public internet? Option A. Deploy a public subnet with an internet gateway for all application servers, allowing direct inbound and outbound access, and use security lists to manage access. Option B. Implement VPN Connect for on-premises connectivity, a NAT gateway for outbound API calls, and network security groups, NSG, for granular application server access control, with no direct internet gateway access for the application subnet. Option C. Utilize an internet gateway for all inbound and outbound traffic, including auditor access and API calls, and configure security lists to restrict access to the application subnet. Option D. Establish VPN Connect for all inbound and outbound traffic, including auditor access and external API calls, and rely solely on security lists for network segmentation. The correct answer is B. Implement VPN Connect for on-premises connectivity, A NAT gateway for outbound API calls, and network security groups, NSG, for granular application server access control, with no direct internet gateway access for the application subnet. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing security, performance, and cost-effectiveness for a critical application while adhering to strict compliance requirements. The need to provide secure, reliable access to a sensitive financial application from both internal users and external auditors, without exposing the entire VCN to the public internet, demands a nuanced networking strategy. The challenge lies in selecting the most appropriate combination of OCI networking components to meet these diverse requirements without introducing unnecessary complexity or security vulnerabilities. Correct approach analysis. The correct approach leverages a combination of VPN Connect for secure, private connectivity from the on-premises financial systems, a NAT gateway for controlled outbound internet access for application updates and external API calls, and network security groups, NSG, to enforce granular security policies at the instance level for the application servers. This strategy ensures that sensitive financial data remains within a private network when communicating with on-premises systems via VPN Connect. The NAT gateway provides a secure and auditable method for the application to access external resources without exposing the application servers directly to the internet. NSGs offer a more dynamic and application-centric security model compared to traditional security lists, allowing for easier management of security rules tied to specific application workloads. This approach aligns with best practices for securing cloud-based financial applications, emphasizing layered security and controlled access, which are implicitly expected under general IT governance and compliance frameworks that govern financial services. Incorrect approaches analysis. An approach that relies solely on an internet gateway for all external connectivity, even for auditor access, would be a significant regulatory and ethical failure. This exposes the application servers directly to the public internet, creating a massive attack surface and violating fundamental security principles for financial data. It would likely contravene data protection regulations and industry-specific compliance mandates that require stringent controls over access to sensitive financial information. Another incorrect approach might involve using only security lists for all network traffic control. While security lists are a valid networking component, relying on them exclusively for granular, application-specific security can become cumbersome and error-prone in complex environments. This could lead to misconfigurations, inadvertently opening ports, and failing to meet the principle of least privilege, which is a cornerstone of secure financial system management. It also lacks the application-centric flexibility of NSGs. Using VPN Connect for all inbound and outbound traffic, including auditor access and application updates, would be inefficient and impractical. VPN Connect is designed for site-to-site connectivity and is not optimized for individual client access or general internet browsing. This would lead to performance degradation and unnecessary complexity, potentially impacting the availability and responsiveness of the financial application, which could have operational and reputational consequences. Professional reasoning. Professionals should approach this scenario by first identifying the distinct traffic flows and their security requirements. Internal on-premises systems to application, external auditors to application, and application to external services. Then they should map these flows to the most appropriate OCI networking services, prioritizing security, compliance, and operational efficiency. A decision-making framework should involve 1. Requirement gathering. Clearly define all access needs, data sensitivity, and compliance mandates. 2. Service mapping. Identify OCI networking services that directly address each requirement. 3. Security layering. Implement defense in depth by combining multiple security controls. 4. Performance and cost evaluation. Assess the impact of chosen services on application performance and budget. 5. Iterative refinement. Review and adjust the architecture based on testing and evolving requirements. Question 7. System analysis indicates a financial services application requires high availability and resilience against localized data center failures, with a strict RTO of under 15 minutes and an RPO of near zero. The application is designed to be stateless and can tolerate some latency between its components. considering OCI's global infrastructure, which approach best satisfies these requirements while optimizing for operational efficiency within a single geographic area. Option A. Deploying all compute instances within a single availability domain in a chosen region, distributing them across different fault domains. Option B. Deploying compute instances across multiple availability domains within a single region, with each instance within an availability domain distributed across different fault domains. Option C. Deploying compute instances across multiple availability domains within a single region without considering fault domains. Option D. Deploying compute instances across multiple regions, with each instance within a region distributed across different fault domains. The correct answer is B. Deploying compute instances across multiple availability domains within a single region, with each instance within an availability domain distributed across different fault domains. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture design, balancing resilience and performance requirements against cost and operational complexity. A professional architect must understand the nuances of OCI's global infrastructure, specifically how regions, availability domains AD, and fault domains FD contribute to high availability and disaster recovery strategies. The challenge lies in selecting the most appropriate OCI constructs to meet specific business objectives without over-engineering or under-provisioning, which can lead to either excessive costs or unacceptable downtime. The need to comply with OCI's architectural best practices, which are implicitly aligned with industry standards for cloud resilience, adds another layer of complexity. Correct approach analysis. The correct approach leverages the hierarchical structure of OCI's global infrastructure to achieve the desired resilience. A region provides a geographically isolated area, protecting against large-scale natural disasters or regional outages. Within a region, availability domains are physically separate data centers, offering protection against localized failures within a single data center. Fault domains, within an AD, further isolate compute, storage, and network resources, preventing a single hardware failure from impacting multiple instances. By distributing resources across multiple ADs within a single region, the solution ensures that a failure in one AD does not affect the availability of the application, while keeping latency low due to the proximity of ADs. This strategy directly aligns with OCI's design principles for high availability and fault tolerance, which are critical for meeting service-level agreements, SLAs, and ensuring business continuity. This approach is professionally sound as it adheres to established cloud resilience patterns and maximizes the benefits of OCI's infrastructure design for availability. Incorrect approach is analysis. Deploying all resources within a single availability domain within a region, while potentially cost-effective initially, fails to provide adequate protection against data center-level failures. A catastrophic event affecting that single AD would render the entire application unavailable, violating the principle of high availability and potentially leading to significant business disruption and financial loss. This approach is ethically questionable as it exposes the business to unacceptable risk without proper mitigation. Spreading resources across multiple regions without a clear disaster recovery strategy or understanding of interregion latency implications can lead to increased complexity and cost without a proportional increase in availability for most applications. While multi-region deployments are crucial for disaster recovery, simply distributing resources without a defined failover mechanism or considering the impact on application performance is not a best practice. This approach can be seen as professionally negligent if it leads to unnecessary operational overhead and performance degradation without a clear benefit. Utilizing only fault domains within a single availability domain provides protection against hardware failures, but does not address broader issues like power outages, network failures affecting an entire data center, or natural disasters impacting a specific geographic location. This is a fundamental misunderstanding of the layered resilience provided by OCI's infrastructure. Professionally, this demonstrates a lack of comprehensive understanding of cloud resilience architecture and a failure to implement a robust high-availability strategy. Professional reasoning. Professionals should approach OCI infrastructure design by first understanding the application's availability and disaster recovery requirements. This involves defining recovery time objectives, RTO, and recovery point objectives, RPO. Next, they should map these requirements to OCI's global infrastructure, considering the trade-offs between resilience, latency, and cost. The hierarchical nature of regions, AD, and FDs should be leveraged systematically. A common best practice for high availability within a single geographic area is to deploy across multiple ADs within a region, utilizing FDs within each AD for compute instance redundancy. For disaster recovery, multi-region strategies are employed. Always consult OCI documentation and best practice guides for the most current recommendations. Question 8. Risk assessment procedures indicate that the customer's e-commerce application experiences highly variable traffic patterns, with unpredictable spikes during promotional events and holidays. The primary business objective is to ensure uninterrupted service availability and optimal customer experience during peak periods, while simultaneously minimizing cloud infrastructure operational costs during periods of low demand. The architecture must be designed to automatically adapt to these fluctuations without manual intervention. Which OCI architectural approach best addresses these requirements for scalability and elasticity? Option A. Implement compute auto-scaling policies for compute instances and utilize an OCI load balancer to distribute incoming traffic across the scaled instances. Option B. Manually scale compute resources up or down based on historical data and anticipated peak loads. Option C. Provision a fixed, high number of compute instances to accommodate the absolute maximum anticipated peak load at all times. Option D. Rely on a single, very large compute instance to handle all traffic, without any scaling or load balancing mechanisms. The correct answer is A. Implement compute auto-scaling policies for compute instances and utilize an OCI load balancer to distribute incoming traffic across the scaled instances. Explanation: scenario analysis. This scenario presents a common challenge in cloud architecture, balancing cost efficiency with the need for high availability and performance during unpredictable demand spikes. The stakeholders' concern about over-provisioning highlights the tension between ensuring service continuity and managing operational expenses. A professionally challenging aspect is translating business requirements for resilience into concrete, scalable, and cost-effective OCI solutions. While adhering to OCI best practices and potential compliance considerations relevant to the Oracle Cloud Infrastructure 2023 Certified Architect Professional Exams implied jurisdiction, which is assumed to be general best practices and OCI-specific guidelines, not tied to a specific country's regulations unless explicitly stated. Correct approach analysis. The correct approach leverages OCI's native auto-scaling and load balancing services to dynamically adjust compute resources based on actual demand. This is best professional practice because it directly addresses the core requirement of elasticity. By configuring auto-scaling policies, the architecture can automatically provision or deprovision compute instances within a compute shape's defined limits. Load balancing ensures that incoming traffic is distributed efficiently across available instances, preventing overload on any single instance and improving overall application responsiveness. This approach aligns with OCI's design principles for cost optimization and performance, ensuring that resources are utilized only when needed, thereby minimizing expenditure while maintaining service levels. From a compliance perspective within the OCI framework, this demonstrates responsible resource management and adherence to performance SLAs. Incorrect approaches analysis. One incorrect approach involves manually scaling resources up or down based on anticipated peak loads. This is professionally unacceptable because it is inherently inefficient and prone to error. Manual scaling often leads to either over-provisioning, resulting in unnecessary costs, a failure in cost management best practices, or under-provisioning, leading to performance degradation or service outages during unexpected demand surges, a failure in availability and reliability best practices. It also fails to capitalize on the dynamic nature of cloud environments. Another incorrect approach is to provision a fixed, high number of compute instances to handle the absolute maximum anticipated load at all times. This is a significant regulatory and ethical failure in terms of resource management and cost governance. It directly contradicts the principles of elasticity and cost optimization, leading to substantial wasted expenditure. From an ethical standpoint, it represents a failure to act as a responsible steward of organizational resources. A third incorrect approach might be to rely solely on a single, very large compute instance to handle all traffic, without any scaling or load balancing. This is professionally unsound, as it creates a single point of failure and severely limits scalability. If that instance fails or becomes overwhelmed, the entire application becomes unavailable, violating fundamental availability and reliability requirements. It also fails to leverage the distributed and scalable nature of cloud infrastructure. Professional reasoning. Professionals should adopt a decision-making process that prioritizes understanding the dynamic nature of application workloads and business requirements. This involves 1. Identifying key performance indicators, KPI and service level objectives, slow for availability, latency, and throughput. 2. Analyzing historical traffic patterns and forecasting potential future demand, acknowledging inherent unpredictability. 3. Leveraging OCI services like compute auto-scaling and load balancing to implement automated, demand-driven resource adjustments. 4. Continuously monitoring performance and costs and iteratively refining auto-scaling policies and resource configurations. 5. Considering the trade-offs between immediate cost savings and the risk of service disruption, always prioritizing business continuity and user experience within budgetary constraints. Question 9. The risk matrix shows a significant upward trend in uncontrolled cloud expenditure, indicating a potential for budget overruns and reduced ROI on OCI investments. Which approach best addresses this escalating cost risk while promoting efficient resource utilization and maintaining agility? Option A. Establish granular budgets for each OCI service and compartment, configure automated alerts for budget thresholds, and implement a regular review process for cost allocation tags to identify and address anomalies proactively. Option B. Defer all cost optimization efforts until after the current development sprint is completed, prioritizing feature delivery over immediate financial considerations. Option C. Focus solely on identifying and terminating underutilized resources only after significant budget overruns have been reported, without any preventative measures in place. Option D. Implement strict, across-the-board spending caps on all OCI services without detailed analysis, forcing teams to reduce usage regardless of actual need or impact. The correct answer is A. Establish granular budgets for each OCI service and compartment, configure automated alerts for budget thresholds, and implement a regular review process for cost allocation tags to identify and address anomalies proactively. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where the rapid adoption of services can outpace cost governance. The risk matrix highlights the potential for uncontrolled spending, which can impact financial predictability and strategic resource allocation. The challenge lies in balancing innovation and agility with fiscal responsibility, ensuring that the organization derives maximum value from its OCI investments without incurring unnecessary expenses. This requires a proactive and systematic approach to cost management, integrating it into the operational and architectural design phases. Correct approach analysis. Implementing a comprehensive cost management strategy that leverages OCI's native tools for tracking, budgeting, and analysis is best professional practice. This approach aligns with the principle of responsible resource utilization, a core tenet of cloud governance. By establishing granular budgets, setting up alerts for cost anomalies, and regularly reviewing cost allocation tags, architects can identify optimization opportunities. This proactive stance not only prevents budget overruns, but also fosters a culture of cost awareness across development and operations teams, leading to more efficient resource provisioning and utilization. This directly supports the organization's financial health and strategic objectives, demonstrating professional accountability. Incorrect approaches analysis. Focusing solely on reactive cost reduction after budget overruns occur represents a failure in proactive governance. This approach is akin to closing the barn door after the horse has bolted, leading to potential financial distress and impacting project timelines. Lacks the foresight required for effective cloud cost management and can be seen as a dereliction of professional duty to ensure fiscal prudence. Implementing cost controls without understanding the underlying resource consumption patterns is inefficient and can lead to unintended consequences, such as impacting application performance or availability. This approach demonstrates a lack of deep analysis and can result in suboptimal resource allocation, failing to achieve true cost optimization. It also risks alienating development teams who may perceive these controls as arbitrary obstacles. Ignoring cost implications during the initial design and architecture phases is a significant professional oversight. This build first, optimize later mentality often leads to deeply entrenched inefficiencies that are far more costly and time-consuming to rectify. It violates the principle of designing for cost-effectiveness from the outset and can result in a legacy of technical debt that hinders future innovation and increases operational expenditure. Professional reasoning. Professionals should adopt a continuous cost management lifecycle. This involves establishing clear cost visibility through tagging and reporting, setting realistic budgets with defined alerts, and regularly analyzing spending patterns to identify optimization opportunities. This analysis should inform architectural decisions, encouraging the selection of cost-effective services and configurations. Furthermore, fostering a shared responsibility for cost management across teams through education and clear accountability is crucial for sustainable success. Question 10. The audit findings indicate a potential risk associated with the current data storage strategy for critical business records, suggesting that data retrieval for compliance purposes might be slower and more costly than anticipated, although specific regulatory mandates were not explicitly cited. The architect is tasked with proposing a revised storage solution that addresses this finding while remaining cost-effective. Option A. Maintain the current storage configuration for critical business records, as the audit findings are not specific enough to warrant immediate changes and cost savings are a priority. Option B. Replicate all critical business records to Oracle Cloud Infrastructure Block Volume with a high-performance tier to guarantee immediate access, regardless of cost implications. Option C. Migrate critical business records to Oracle Cloud Infrastructure Object Storage Standard tier to ensure timely and cost-effective access for potential compliance reviews and audits. Option D. Archive all critical business records to Oracle Cloud Infrastructure Object Storage Archive tier to minimize ongoing storage costs, assuming retrieval needs are minimal. Correct answer is C. Migrate critical business records to Oracle Cloud Infrastructure Object Storage Standard tier to ensure timely and cost-effective access for potential compliance reviews and audits. Explanation. This scenario presents a professional challenge due to the conflict between cost optimization and data accessibility requirements, particularly in the context of regulatory compliance and potential future audit needs. The architect must balance immediate financial pressures with the long-term implications of data storage choices, ensuring that the chosen solution adheres to best practices for data management and security. The core of the challenge lies in interpreting the audit's findings, which highlight a potential risk without specifying the exact nature of the risk or the regulatory mandate being potentially violated. This ambiguity requires a proactive and risk-averse approach. The correct approach represents best professional practice because it prioritizes data integrity, accessibility for compliance, and future auditability. By migrating critical data to a more accessible storage tier like Oracle Cloud Infrastructure, OSI Object Storage with a standard tier, the architect ensures that data is readily available for review and retrieval. This aligns with general principles of good data governance and the implicit expectation that data relevant to business operations and potential regulatory scrutiny should not be excessively difficult or costly to access. While cost is a factor, the potential cost of non-compliance or an inability to produce data during an audit far outweighs the incremental storage costs. This approach demonstrates a commitment to operational resilience and adherence to potential, albeit unspecified, regulatory obligations. An incorrect approach that involves archiving all data to OCI archive storage, even if it's infrequently accessed, presents significant regulatory and ethical failures. Archive storage is designed for long-term retention of data that is rarely accessed and incurs retrieval costs and latency. If the audit findings imply a need for prompt access to this data for compliance verification, using archive storage would create a bottleneck, potentially leading to noncompliance with data access timelines stipulated by regulations. This could be interpreted as a failure to adequately safeguard data for audit purposes, potentially exposing the organization to fines or reputational damage. Another incorrect approach, which is to ignore the audit findings due to cost concerns and maintain the current storage configuration, is ethically and professionally unsound. Ignoring audit findings, especially those related to data management and potential compliance risks, is a dereliction of professional duty. It demonstrates a lack of due diligence and a failure to proactively address potential issues. This can lead to significant financial and legal repercussions if a subsequent audit or incident reveals data inaccessibility or noncompliance. Ethically, it prioritizes short-term cost savings over the organization's long-term security and compliance posture. The professional decision-making process for similar situations should involve a thorough understanding of the audit's scope and implications. When faced with ambiguous findings, the architect should seek clarification from the auditors or relevant compliance officers. If clarification is not immediately available, a risk-based approach should be adopted, erring on the side of caution. This involves assessing the potential impact of various storage tiers on data accessibility, retrieval times, and associated costs, always considering the most stringent potential regulatory requirements. The decision should be documented, including the rationale for the chosen storage tier and any assumptions made. Regular review of storage strategies in light of evolving business needs and regulatory landscapes is also crucial. Question 11. Quality control measures reveal that a critical financial application deployed on Oracle Cloud infrastructure is not adequately protected against common web exploits, and its data transmission protocols are not consistently enforced to use strong encryption. The application handles highly sensitive customer financial information, and the current network segmentation strategy is considered too broad, potentially exposing more resources than necessary. The architecture team needs to design a comprehensive security solution that adheres to best practices for securing sensitive data at rest and in transit, implementing robust network segmentation, and protecting the application layer while minimizing performance impact. Option A. Implement a VCN with broad security lists. Use older TLS versions for data in transit to reduce overhead, and store sensitive data unencrypted at rest, focusing primarily on perimeter security with a single firewall. Option B. Implement a virtual cloud network, VCN, with granular network security groups, NSG, and security lists to segment the application tier. Enforce TLS 1.2+ for all API calls and client connections. Encrypt data at rest using OCI Vault for key management, and deploy OCI Web Application Firewall, WAF, to protect against web exploits and DDoS attacks. Option C. Disable encryption for data at rest to improve application performance and rely solely on basic security lists for network access control, assuming that the application's internal logic prevents unauthorized data access. Option D. Utilize OCI Load Balancer with SSL termination and rely on application-level security features for data protection, while keeping network segmentation minimal to simplify management. Correct answer is B. Implement a virtual cloud network, VCN, with granular network security groups, NSG, and security lists to segment the application tier. Enforce TLS 1.2+ for all API calls and client connections. Encrypt data at rest using OCI Vault for key management, and deploy OCI Web Application Firewall, WAF, to protect against web exploits and DDoS attacks. Explanation. Scenario analysis. This scenario presents a common challenge in cloud security architecture, balancing robust security controls with the operational needs of a sensitive application. The core difficulty lies in implementing effective network segmentation and data protection mechanisms without introducing unacceptable latency or complexity that could impact the application's performance and user experience. The sensitive nature of the financial data further elevates the stakes, demanding strict adherence to security best practices and regulatory compliance. Professionals must carefully consider the trade-offs between different security solutions, ensuring that the chosen approach is both secure and practical. Correct approach analysis. The correct approach involves a multi-layered security strategy that leverages OCI's native security services to achieve granular control and comprehensive protection. Implementing a virtual cloud network, VCN, with strict security list and network security group, NSG, rules is fundamental for network segmentation. This isolates the application tier from other network segments and limits inbound and outbound traffic to only what is explicitly required. Encrypting data at rest using OCI Vault for key management ensures that sensitive financial data is protected even if the underlying storage is compromised. For data in transit, enforcing TLS 1.2+ 2 or higher for all API calls and client connections guarantees confidentiality and integrity. Utilizing OCI Web Application Firewall, WAF, to protect against common web exploits and DDoS attacks adds another critical layer of defense. This combination of network segmentation, robust encryption, secure communication protocols, and application-level security directly addresses the requirements for securing sensitive financial data and aligns with industry best practices and regulatory expectations for data protection and secure network design. Incorrect approaches analysis. One incorrect approach would be to rely solely on basic security lists without NSGs for fine-grained control. This lacks the necessary specificity to restrict traffic to individual resources within a subnet, potentially exposing more of the application's attack surface than intended. It fails to meet the principle of least privilege at the network level. Another incorrect approach would be to disable encryption for data at rest to improve performance. This is a severe regulatory and ethical failure, as it directly violates data protection mandates and exposes sensitive financial data to significant risk of unauthorized access and breaches. It demonstrates a disregard for fundamental security principles and legal obligations. A third incorrect approach might involve implementing encryption for data in transit, but using outdated or weak cipher suites. This leaves data vulnerable to interception and decryption, failing to provide adequate confidentiality and integrity, and potentially violating compliance standards that mandate strong encryption. Professional reasoning. Professionals should approach such scenarios by first understanding the specific security and compliance requirements for the data being handled. This involves identifying relevant regulations, e.g., PCI DSS for financial data, if applicable within the exam's jurisdiction, and internal security policies. The next step is to map these requirements to OCI's security services, prioritizing native solutions that offer integrated security and management. A risk-based approach is crucial, where potential threats and vulnerabilities are identified, and security controls are implemented to mitigate them effectively. This involves a thorough assessment of the application's architecture, data flow, and dependencies. Finally, continuous monitoring and regular security audits are essential to ensure that the implemented security measures remain effective and compliant over time. Question 12. Regulatory review indicates that a financial services organization is planning to migrate a large, mission-critical Oracle database from its on-premises data center to Oracle Cloud Infrastructure, OCI. The migration must minimize downtime, ensure data consistency throughout the process, and maintain the integrity of sensitive financial data. The organization requires a robust solution for extracting, transforming, and loading data into OCI, with the ability to handle ongoing data synchronization until the queued over. Which OCI data integration and migration strategy best aligns with these requirements and professional best practices for cloud adoption? Option A. Develop custom Python scripts to extract data from the on-premises Oracle database, stage it in OCI object storage, and then use OCI compute instances to process and load the data into OCI databases. Option B. Implement OCI data integration to build and manage ETL/ELT pipelines, leveraging its capabilities for data transformation, orchestration, and integration with OCI services, potentially combined with OCI Database Migration Service for initial seeding and ongoing replication. Option C. Manually export data from the on-premises Oracle database into flat files, upload these files to OCI object storage, and then use SQL* loader to import them into OCI databases. Option D. Utilize Oracle Golden Gate for continuous replication of the on-premises database to an OCI database, without implementing a separate data integration service for transformations or complex data flows. The correct answer is B. Implement OCI data integration to build and manage ETL/ELT pipelines, leveraging its capabilities for data transformation, orchestration, and integration with OCI services, potentially combined with OCI Database Migration Service for initial seeding and ongoing replication. Explanation. Scenario analysis. This scenario presents a common challenge in cloud migration projects, ensuring data integrity and compliance during a large-scale data migration from an on-premises Oracle database to Oracle Cloud Infrastructure, OCI. The primary challenge lies in selecting a data integration and migration strategy that minimizes downtime, maintains data consistency, and adheres to potential regulatory requirements for data handling and security, even if not explicitly stated in the prompt. The assumption of compliance is paramount in professional OCI deployments. Need to balance performance, cost, and risk requires careful consideration of various OCI services and their suitability for the specific data characteristics and business objectives. Correct approach analysis. The correct approach leverages OCI data integration, a fully managed, serverless ETL/ELT service. This service is designed for building robust data pipelines that can ingest data from various sources, transform it, load it into OCI targets. For a large-scale migration from an on-premises Oracle database, data integration offers features like change data capture, CDC capabilities, when combined with other OCI services or tools, and parallel processing, which are crucial for minimizing downtime and ensuring data consistency. Its serverless nature also reduces operational overhead and scales automatically, aligning with cloud best practices. Furthermore, using OCI's native services promotes a more integrated and secure environment, simplifying management and auditing. This approach represents best professional practice because it utilizes a purpose-built, scalable, and managed service that directly addresses the complexities of data migration and integration within the OCI ecosystem, thereby optimizing for efficiency and reliability. Incorrect approaches analysis. Manually scripting data extraction, transformation, and loading processes using custom code and external tools, while technically feasible, introduces significant risks. This approach is professionally unacceptable due to increased development and maintenance overhead, higher potential for errors, and a lack of inherent scalability and resilience. It also bypasses OCI's managed services, potentially leading to security vulnerabilities if not meticulously managed and audited. From a regulatory perspective, custom solutions are harder to validate and audit for compliance compared to managed services with built-in governance features. Utilizing OCI object storage as a staging area for raw data dumps and then processing them with custom compute instances, e.g., OCI compute with custom scripts, is an improvement over purely manual scripting but still falls short. While object storage is cost-effective for bulk data, the subsequent processing on custom compute instances reintroduces the challenges of manual management, scaling, and error handling. This approach lacks the integrated transformation and orchestration capabilities of OCI data integration, making it less efficient for complex data pipelines and potentially leading to data inconsistencies if not carefully orchestrated. It also requires more effort to ensure data security and compliance throughout the processing stages. Relying solely on database replication tools without a comprehensive integration strategy can lead to data silos and integration challenges downstream. While replication is excellent for keeping data synchronized, it doesn't inherently handle complex transformations or orchestrate data flows across different OCI services. This can result in a migration that is technically complete but functionally incomplete, failing to meet the broader data integration requirements of the target OCI environment. It also might not be the most cost-effective or performant solution for a one-time migration scenario compared to a dedicated integration service. Professional reasoning. Professionals should approach data migration and integration by first understanding the business requirements, data volume, velocity, variety, and the acceptable downtime. They should then evaluate OCI's native services that are designed for these specific tasks, prioritizing managed and serverless options for scalability, reliability, and reduced operational burden. A thorough assessment of security and compliance requirements should guide the selection of services and the design of the data pipelines. When faced with multiple options, the decision-making process should favor solutions that offer a balance of performance, cost-effectiveness, ease of management, and adherence to best practices for cloud data integration. Question 13. Assessment of how to design a storage solution for a new OCI deployment where the finance department mandates significant cost optimization. The R&D team requires high-performance storage for active development databases and code repositories, and the legal department requires immutable, long-term archival of audit logs and compliance-related documents with guaranteed retrieval times. Option A. Implement a tiered storage strategy using OCI object storage for archival, OCI file storage for shared code repositories, and high-performance OCI block volumes for active development databases. Option B. Utilize OCI block volume with the highest performance tier for all data to ensure maximum accessibility and speed for all use cases. Option C. Configure OCI file storage for all data, balancing performance and cost for all requirements. Option D. Deploy OCI archive storage for all data to achieve the lowest possible storage costs. The correct answer is A. Implement a tiered storage strategy using OCI object storage for archival, OCI file storage for shared code repositories, and high-performance OCI block volumes for active development databases. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing diverse stakeholder requirements for data storage. The finance department prioritizes cost reduction, while the R&D team demands high performance for active development, and the legal team insists on long-term, immutable archival for compliance. The challenge lies in selecting a single, unified storage solution that can adequately address these conflicting needs without compromising data integrity, accessibility, or incurring excessive costs. A failure to properly align storage choices with these requirements can lead to budget overruns, performance bottlenecks, and regulatory noncompliance. Correct approach analysis. The correct approach involves a tiered storage strategy that leverages Oracle Cloud Infrastructures, OSI, diverse storage services. This strategy aligns with best practices for cost optimization and performance tuning. By using OCI object storage for infrequent access and archival, OCI file storage for shared development environments, and OCI block volume with high-performance tiers for active development databases, each stakeholder's primary concern is addressed. Object storage cost-effectiveness and durability meet legal and financial requirements for archival. File storage provides a scalable, shared platform for development teams. High-performance block volumes ensure the R&D team has the necessary IOPS and throughput for their critical workloads. This multi-service approach is ethically sound as it avoids overspending finance, ensures operational efficiency R&D, and guarantees compliance legal. It represents professional best practice by demonstrating a thorough understanding of OCI's capabilities and applying them pragmatically to meet complex business needs. Incorrect approaches analysis. Choosing a single, high-performance storage solution for all data, such as exclusively using OCI block volume with the highest performance tier for all data, would be a regulatory and ethical failure. This approach would significantly inflate costs, failing to meet the finance department's requirement for cost reduction. It is professionally unacceptable because it demonstrates a lack of cost consciousness and an inability to apply the principle of least privilege to resource allocation. Opting solely for the cheapest storage option, like OCI archive storage for all data, would be a significant performance and compliance failure. While it would satisfy the finance department's cost concerns, it would cripple the R&D team's development efforts due to extremely high latency and low throughput. Furthermore, it might not meet the legal team's requirements for timely access to certain data, potentially leading to regulatory noncompliance if specific retrieval times are mandated. This approach is professionally unsound, as it prioritizes one stakeholder's need to the detriment of others and risks operational failure and legal repercussions. Selecting a solution that offers a compromise in performance and cost but lacks the immutability required for legal archival, such as using OCI file storage for all data, would also be a regulatory and ethical failure. While it might offer a balance for active data, it would not satisfy the legal team's requirement for tamper-proof, long-term storage, potentially leading to breaches of data retention policies and legal penalties. This demonstrates a failure to understand and implement critical compliance requirements, which is a serious ethical lapse in professional practice. Professional reasoning. Professionals should approach storage design by first identifying and prioritizing all stakeholder requirements, including performance, cost, access patterns, and compliance mandates. They should then map these requirements to the most appropriate OCI storage services, considering a tiered approach where different data types reside on services best suited to their characteristics. This involves understanding the trade-offs between different storage tiers and services. A critical step is to validate the proposed solution against all identified requirements and potential regulatory implications. This systematic process ensures that the chosen solution is not only technically sound, but also economically viable and legally compliant, reflecting a responsible and ethical approach to cloud architecture. Question 14. Quality control measures reveal that a financial services organization operating within the United States is designing a new OCI-based trading platform. The platform handles sensitive customer financial data and must comply with U.S. financial regulations that mandate robust business continuity and data protection. The organization has defined an RTO of 4 hours and an RPO of 1 hour for critical trading functions. Which of the following OCI architectural approaches best aligns with these requirements and regulatory obligations? Option A. Deploying critical trading application components and their databases across multiple OCI regions, with manual failover procedures and a synchronous database replication configured with a 24-hour RPO. Option B. Deploying critical trading application components and their associated databases across multiple OCI availability domains within a single OCI region, with automated failover configured, and utilizing OCI block volume replication for data redundancy with a 1-hour RPO. Option C. Deploying all critical trading application components and their databases within a single OCI availability domain in one OCI region, with daily backups of all data stored in OCI object storage. Option D. Deploying critical trading application components and their databases across multiple OCI availability domains within a single OCI region, with automated failover configured, and utilizing OCI object storage for daily backups to a different OCI region. The correct answer is B. Deploying critical trading application components and their associated databases across multiple OCI availability domains within a single OCI region, with automated failover configured, and utilizing OCI block volume replication for data redundancy with a 1-hour RPO. Explanation: Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing robust high availability (HA) and disaster recovery (DR) with cost-effectiveness, all while adhering to stringent regulatory compliance requirements. The professional challenge lies in interpreting and applying these regulations to technical design decisions, ensuring that the chosen OCI services and configurations meet both business continuity objectives and legal mandates. The need for deep understanding of RTO, recovery time objective, and RPO, recovery point objective, is paramount, as these metrics directly influence the complexity and cost of the HA/DR solution and have direct implications for regulatory adherence. Failure to correctly implement these can lead to significant business disruption, financial penalties, and reputational damage. Correct approach analysis. The correct approach involves leveraging OCI's native HA and DR capabilities in a manner that directly addresses the defined RTO and RPO, while also aligning with the specified regulatory framework. This typically means utilizing services like OCI availability domains and regions for redundancy, implementing automated failover mechanisms, and ensuring data is replicated to a geographically separate DR region with appropriate RPO targets. For instance, using OCI block volume replication or database data guard in a DR configuration, coupled with a well-defined and regularly tested DR plan, demonstrates a commitment to meeting regulatory requirements for data integrity and service availability. The regulatory justification stems from the implicit or explicit requirements within the specified framework, e.g., financial services regulations, healthcare data protection laws that mandate resilience and data protection against disruptions. Adhering to these principles ensures that the organization can continue critical operations and protect sensitive data even in the face of a disaster, thereby meeting its legal and ethical obligations. Incorrect approaches analysis. An approach that relies solely on single availability domain deployments for critical services, even with backups, fails to meet HA requirements and significantly increases RTO/RPO in the event of an availability domain failure. This is a regulatory failure because many compliance frameworks mandate resilience against infrastructure failures, and a single AD is not inherently resilient. Implementing a DR solution that only involves manual data backups to object storage without a defined automated failover or recovery process will likely exceed acceptable RTO/RPO targets. This is a regulatory failure as it demonstrates a lack of preparedness for a disaster, potentially violating regulations that require timely restoration of critical services and data. Choosing a DR region that is not geographically sufficiently distant or that does not meet the specific compliance requirements of the regulatory framework, e.g., data sovereignty laws, is also a significant failure. This can lead to non-compliance with data residency rules and may not provide adequate protection against regional disasters, thus failing to meet the spirit and letter of regulatory mandates. Professional reasoning. Professionals must first thoroughly understand the specific regulatory framework applicable to their organization and its data. This involves identifying explicit requirements for availability, data durability, RTO, and RPO. Next, they should translate these regulatory requirements into concrete technical objectives for HA and DR. The OCI service catalog should then be evaluated to identify the most appropriate and cost-effective services that can meet these objectives. Crucially, a comprehensive DR plan must be developed, documented, and regularly tested to validate its effectiveness and ensure it aligns with regulatory expectations. This iterative process of understanding requirements, designing solutions, and validating through testing is fundamental to professional decision-making in this domain. Question 15. Implementation of a hybrid cloud architecture requires a robust strategy for connecting on-premises data centers to Oracle Cloud Infrastructure, OSI, and synchronizing critical business data. The organization handles sensitive customer information and must ensure high availability and data integrity while minimizing latency for core applications. Which of the following approaches best addresses these requirements for secure and reliable hybrid cloud connectivity and data synchronization? Option A. Implement a leased line connection from the on-premises data center to a colocation facility, and then establish a VPN connection from the colocation facility to OCI. Rely on periodic data exports and imports for synchronization. Option B. Configure a single, unencrypted connection over the public internet for data transfer, relying on application-level security for data protection. Use basic file copy utilities for data synchronization. Option C. Utilize only ISEC VPN tunnels established over the public internet for all connectivity between on-premises and OCI. Employ scheduled manual backups and restores for data synchronization. Option D. Establish a dedicated OCI Fast Connect circuit for primary connectivity, supplemented by an ISEC VPN over the public internet for redundancy. Implement Oracle Data Guard for database synchronization and Golden Gate for transactional data replication to ensure high availability and data consistency. Correct answer is D. Establish a dedicated OCI Fast Connect circuit for primary connectivity, supplemented by an ISEC VPN over the public internet for redundancy. Implement Oracle Data Guard for database synchronization and Golden Gate for transactional data replication to ensure high availability and data consistency. Explanation. This scenario presents a common challenge in hybrid cloud architectures, ensuring secure, reliable, and performant connectivity between on-premises infrastructure and Oracle Cloud Infrastructure, OSI, while adhering to stringent data governance and compliance requirements. The professional challenge lies in balancing the need for seamless data flow and application integration with the imperative to protect sensitive data, maintain operational continuity, and meet regulatory obligations. Careful judgment is required to select the most appropriate connectivity and synchronization strategy that aligns with business needs and risk appetite. The correct approach represents best professional practice because it prioritizes a dedicated, secure, and resilient network connection. Using OCI Fast Connect with a VPN for redundancy and leveraging OCI's robust data synchronization services like Oracle Data Guard or Golden Gate ensures high availability, disaster recovery capabilities, and data integrity. This strategy directly addresses the need for secure data transfer and minimizes latency, which are critical for hybrid cloud operations. It aligns with best practices for data protection and compliance by establishing a controlled and monitored pathway for data movement, thereby reducing the attack surface and ensuring data remains within defined security perimeters. An incorrect approach that relies solely on public internet VPNs for critical data synchronization poses significant regulatory and ethical failures. Public internet connections are inherently less secure and more susceptible to interception, data breaches, and denial of service attacks. This could lead to noncompliance with data privacy regulations, e.g., GDPR if applicable, or specific U.S. federal/state regulations concerning sensitive data that mandate secure data handling and protection. Ethically, it demonstrates a disregard for client or organizational data security, potentially leading to reputational damage and legal liabilities. Another incorrect approach that neglects robust data synchronization mechanisms, opting for manual or ad hoc file transfers, introduces risks of data inconsistency, corruption, and significant downtime. This failure to implement automated and reliable synchronization directly contravenes best practices for business continuity and disaster recovery. It can lead to operational inefficiencies and, in regulated industries, may violate compliance mandates requiring accurate and timely data availability. The professional reasoning process for such a scenario should involve a thorough risk assessment of data sensitivity, performance requirements, and regulatory mandates. Architects must evaluate connectivity options based on security, reliability, and cost. Data synchronization strategies should be chosen based on data volume, transaction frequency, consistency requirements, and disaster recovery objectives. A layered security approach, including encryption in transit and at rest, access controls, and continuous monitoring, is paramount. Professionals should always consult relevant OCI documentation and industry best practices for hybrid cloud design and data management to ensure a compliant and robust solution. Question 16. Operational review demonstrates that a critical customer-facing web application hosted on OCI is experiencing significant performance degradation for users located in different geographical regions. The application's backend is deployed on OCI compute instances in a single region. Analysis indicates that the primary bottleneck is network latency between the users and the OCI region. Which of the following architectural changes represents the most effective and compliant solution to improve application performance for a globally distributed user base? Option A. Migrating the entire application stack to a new OCI region that is geographically closer to the majority of users. Option B. Implementing a custom, multi-region network routing solution using OCI VPN Connect and custom routing tables. Option C. Increasing the size and number of OCI compute instances in the existing region. Option D. Deploying Oracle Cloud Infrastructure Content Delivery Network, OCI CDN, to cache application content closer to end users. The correct answer is D. Deploying Oracle Cloud Infrastructure Content Delivery Network, OCI CDN, to cache application content closer to end users. Explanation. Scenario analysis. The scenario presents a common challenge in cloud architecture where a critical application's performance is degrading due to network latency. The challenge lies in identifying the root cause and implementing a solution that balances performance, cost, security, and compliance within the Oracle Cloud Infrastructure (OCI) framework. A hasty or ill-informed decision can lead to further performance issues, increased operational costs, or even security vulnerabilities, all of which have significant business implications. Correct approach analysis. Implementing a content delivery network (CDN) service like Oracle Cloud Infrastructure Content Delivery Network (OCI CDN) is the best professional practice. This approach directly addresses the symptom of high latency for geographically dispersed users by caching content closer to them. This aligns with OCI's best practices for optimizing application delivery and user experience. From a regulatory and ethical standpoint, improving performance and availability for users is a responsible action, ensuring the service meets its intended purpose and user expectations without introducing new risks. Incorrect approaches analysis. Choosing to simply increase the compute instance size without investigating the network path is a failure to perform due diligence. This approach is a brute force solution that doesn't address the underlying network latency, potentially leading to wasted resources and increased costs without a proportional performance gain. Ethically, it's irresponsible to incur unnecessary costs for the organization without a clear understanding of the problem. Migrating the application to a different region without a thorough analysis of network connectivity and user distribution is also a flawed approach. While it might reduce latency for some users, it could increase it for others and introduce new complexities in data management and interregion communication. This could violate service-level agreements, SLAs, if not carefully managed, and represents a failure to apply a targeted solution. Implementing a complex, custom network routing solution without leveraging OCI's managed services is an unnecessary escalation. This approach introduces significant operational overhead, increases the potential for misconfiguration, and bypasses OCI's built-in optimizations. It demonstrates a lack of understanding of OCI's capabilities and could lead to security vulnerabilities if not expertly implemented, failing to adhere to best practices for secure and efficient cloud operations. Professional reasoning. Professionals should approach performance degradation issues by first performing a comprehensive diagnostic. This involves analyzing metrics from various layers of the OCI stack, including compute, storage, and networking. Once the root cause is identified, the solution should be evaluated against OCI best practices, considering factors like cost-effectiveness, scalability, security, and maintainability. The decision-making process should prioritize solutions that leverage managed OCI services where appropriate, as these are designed for optimal performance and security within the OCI ecosystem. Question 17. Operational review demonstrates that the organization's Oracle Cloud infrastructure, OCI, spending has increased significantly over the past quarter, with no corresponding increase in business value or application performance metrics. The architecture team is tasked with identifying and implementing cost-saving measures. Which of the following approaches best addresses this situation while adhering to best practices for cloud cost management and resource governance? Option A. Halt all new OCI deployments and freeze all existing resource configurations until a detailed cost-cutting plan can be developed over the next 6 months. Option B. Focus solely on negotiating discounts with OCI account management without analyzing current resource utilization or identifying specific areas of overspending. Option C. Implement a comprehensive tagging strategy for all OCI resources. Leverage OCI cost analysis and budgets to identify underutilized resources, and explore right-sizing opportunities for compute, storage, and database services based on actual usage data. Option D. Immediately reduce the size of all compute instances and storage volumes by 20% across all environments to achieve immediate savings. The correct answer is D. Immediately reduce the size of all compute instances and storage volumes by 20% across all environments to achieve immediate savings. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments: the continuous need to balance performance and cost. The operational review highlighting increased OCI spending without a proportional increase in business value necessitates a strategic approach to cost optimization. The challenge lies in identifying the root causes of the cost overrun and implementing effective, sustainable solutions without negatively impacting application availability or performance. This requires a deep understanding of OCI services, their pricing models, and the specific workloads running on the platform. Furthermore, the pressure to demonstrate ROI on cloud investments adds a layer of urgency and requires careful consideration of long-term implications. Correct approach analysis. The correct approach involves a multifaceted strategy that begins with a thorough analysis of resource utilization and cost drivers. This includes leveraging OCI's native cost management tools, such as cost analysis and budgets, to pinpoint areas of overspending. Right-sizing compute instances, storage volumes, and database services based on actual performance metrics is crucial. This means identifying underutilized resources that can be scaled down or consolidated. Additionally, exploring OCI's cost-saving features like reserved instances for predictable workloads and autonomous database options, which can offer cost efficiencies for certain use cases, is a best practice. Implementing tagging strategies for better cost allocation and accountability is also fundamental. This approach aligns with the principle of responsible cloud resource management, ensuring that investments are aligned with business objectives and that resources are utilized efficiently, thereby maximizing the value derived from the OCI platform. This proactive and data-driven methodology is essential for maintaining financial governance and demonstrating fiscal responsibility within the organization. Incorrect approach is analysis. One incorrect approach is to immediately implement broad, across-the-board resource reductions without a detailed analysis. This could lead to performance degradation, application instability, and potential service disruptions, which would be a failure in delivering reliable services and could have significant business and reputational consequences. Ethically, it represents a failure to adequately assess the impact of changes on end users and business operations. Another incorrect approach is to solely rely on manual monitoring and ad hoc adjustments without utilizing OCI's automated cost management tools. This is inefficient, prone to human error, and unlikely to identify all cost-saving opportunities. It also fails to establish a systematic and repeatable process for cost optimization, which is a hallmark of professional cloud management. This approach lacks the rigor required for effective financial governance. A third incorrect approach is to ignore the potential for reserved instances or other commitment-based discounts, opting instead to continue paying on-demand rates for predictable workloads. This represents a missed opportunity for significant cost savings and demonstrates a lack of strategic financial planning. It can be seen as a failure to act in the best financial interest of the organization, potentially leading to unnecessary expenditure. Professional reasoning. Professionals should approach cost optimization by first establishing a clear understanding of current spending patterns and resource utilization through OCI's native tools. This data-driven approach allows for targeted interventions. The decision-making process should prioritize solutions that offer the greatest cost saving with the least impact on performance and availability. This involves a phased implementation, starting with low-risk optimizations like right-sizing, and then progressing to more strategic options like reserved instances. Continuous monitoring and iterative refinement are key to sustained cost efficiency. Professionals must also consider the total cost of ownership, including the operational overhead of managing resources, when evaluating different optimization strategies. Question 18. The monitoring system demonstrates that a critical customer-facing application on Oracle Cloud infrastructure is consistently underutilized during off-peak hours, leading to significant operational costs. A business stakeholder has requested an immediate reduction in cloud expenditure, suggesting a drastic scaling down of compute and database resources to match the lowest observed utilization levels, even if it means the application may struggle to respond to sudden traffic spikes. Option A. Implement a phased approach to right-sizing compute and database resources based on historical utilization data, coupled with the implementation of auto-scaling policies that dynamically adjust capacity based on real-time demand, ensuring cost optimization without compromising performance or availability. Option B. Migrate the application to a cheaper, less resilient compute and database service tier that offers lower per-unit costs, without conducting a thorough analysis of its impact on the application's fault tolerance and recovery capabilities. Option C. Immediately scale down all compute and database resources to match the absolute minimum utilization observed, accepting the risk of performance degradation and potential service unavailability during periods of unexpected traffic surges. Option D. Disable non-essential monitoring and alerting services for the application during off-peak hours to reduce associated costs, relying on manual checks for critical issues. Correct answer is A. Implement a phased approach to right-sizing compute and database resources based on historical utilization data, coupled with the implementation of auto-scaling policies that dynamically adjust capacity based on real-time demand, ensuring cost optimization without compromising performance or availability. Explanation. This scenario presents a professional challenge rooted in balancing immediate cost pressures against long-term architectural integrity and compliance with Oracle Cloud infrastructure, OCI best practices, which are implicitly tied to regulatory expectations for service availability and data integrity. The core dilemma lies in a potential conflict between a business directive for cost reduction and the architect's responsibility to maintain a robust, scalable, and fault-tolerant cloud environment. The correct approach represents best professional practice because it prioritizes a data-driven phase strategy that aligns with OCI's design principles for elasticity, scalability, high availability, and fault tolerance. This approach ensures that any cost optimization efforts do not compromise the application's ability to handle fluctuating demand, recover from failures, or meet service level agreements, SLAs. It also demonstrates ethical responsibility by avoiding hasty decisions that could lead to service degradation or data loss, which could have significant business and potentially regulatory implications if the application handles sensitive data or is critical to business operations. Adhering to OCI's recommended architectural patterns for resilience and performance is a de facto standard for professional cloud architects operating within the OCI ecosystem. An incorrect approach that immediately scales down resources without thorough analysis fails to uphold the principle of elasticity and scalability. This can lead to performance issues during peak loads, impacting user experience and potentially violating SLAs. Ethically, this demonstrates a disregard for the application's functional requirements and the business's reliance on its consistent availability. Another incorrect approach that involves disabling monitoring or alerting mechanisms to save costs is a severe ethical and professional failing. This directly undermines the principles of high availability and fault tolerance by removing the ability to detect and respond to issues promptly. It creates a blind spot, increasing the risk of undetected failures, prolonged downtime, and data corruption, which could have severe business and legal repercussions. This approach prioritizes short-term cost savings over fundamental operational integrity and risk management. A third incorrect approach that involves migrating to a less resilient but cheaper service tier without a comprehensive impact assessment ignores the core design principles of high availability and fault tolerance. This decision, driven solely by cost, could expose the application to increased downtime and data loss, failing to meet the expected resilience of a cloud-native application. Professionally, it shows a lack of due diligence and a failure to consider the broader implications of architectural changes on business continuity. The professional reasoning process for similar situations should involve a structured approach. 1. Understand the business objective. Clearly define the cost reduction goals and their urgency. 2. Assess current architecture. Analyze the existing OCI architecture, its performance metrics, resource utilization, and resilience mechanisms. 3. Identify optimization opportunities. Pinpoint areas where costs can be reduced without compromising core principles, e.g., right-sizing reserved instances, storage tiering. 4. Evaluate impact. For each potential optimization, conduct a thorough impact assessment on elasticity, scalability, high availability, fault tolerance, and security. 5. Develop a phased plan. Propose a gradual implementation of cost-saving measures, with continuous monitoring and validation at each stage. 6. Communicate and document. Clearly communicate the proposed changes, their rationale, and potential risks to stakeholders, and maintain comprehensive documentation. 7. Prioritize resilience. Ensure that any cost-saving measures do not compromise the application's ability to meet its defined SLAs and recovery objectives. Question 19. Investigation of how an organization can strategically leverage cloud computing principles to optimize its IT operations and accelerate innovation in response to rapid business growth, while ensuring adherence to its existing regulatory framework. Option A. Immediately migrate all existing on-premises applications to a public cloud IaaS offering to achieve rapid scalability and cost efficiencies, without a detailed analysis of individual application needs or security implications. Option B. Exclusively adopt a private cloud model for all new deployments to mitigate perceived security risks, foregoing the potential benefits of public or hybrid cloud solutions for agility and cost optimization. Option C. Conduct a comprehensive assessment of business objectives, current IT infrastructure, and regulatory compliance requirements to determine the most suitable combination of IaaS, PaaS, and SaaS, and public, private, hybrid, or multi-cloud deployment models for different workloads. Option D. Prioritize the selection of the lowest-cost cloud services available across various providers to maximize immediate cost savings, without a thorough evaluation of their functional suitability, performance, or security features. The correct answer is C. Conduct a comprehensive assessment of business objectives, current IT infrastructure, and regulatory compliance requirements to determine the most suitable combination of IaaS, PaaS, and SaaS, and public, private, hybrid, or multi-cloud deployment models for different workloads. Explanation. Scenario analysis. This scenario presents a common challenge in cloud adoption, balancing the desire for rapid innovation and cost efficiency with the imperative to maintain robust security and compliance. The organization is experiencing growth, which naturally increases the complexity of its IT infrastructure and the potential attack surface. Without a clear understanding of cloud computing's fundamental characteristics and service/deployment models, the team risks making architectural decisions that could lead to security vulnerabilities, compliance violations, and inefficient resource utilization. The pressure to deliver new features quickly can exacerbate these risks if not managed with a strategic, well-informed approach. Correct approach analysis. The correct approach emphasizes a foundational understanding of cloud computing concepts and their implications for the organization's specific needs. This involves a thorough assessment of the organization's current IT landscape, business objectives, and risk tolerance. By evaluating IaaS, PaaS, and SaaS models, the team can determine the most appropriate level of abstraction for different workloads, optimizing for control, management overhead, and innovation speed. Similarly, understanding public, private, hybrid, and multi-cloud deployment models allows for strategic placement of workloads based on factors like data sovereignty, security requirements, and existing infrastructure investments. This methodical evaluation ensures that the chosen cloud strategy aligns with business goals, regulatory obligations, and security best practices, leading to a more secure, compliant, and cost-effective cloud environment. This aligns with the general principles of responsible IT governance and risk management expected in professional practice. Incorrect approaches analysis. One incorrect approach involves immediately migrating all existing on-premises applications to a public cloud IaaS offering without a detailed assessment. This fails to consider the varying needs of different applications and could result in overspending on resources that could be managed more efficiently with PaaS or SaaS. Furthermore, it might overlook specific security configurations required for sensitive data, potentially leading to compliance breaches. Another incorrect approach is to exclusively adopt a private cloud model due to perceived security concerns, without exploring the benefits of hybrid or multi-cloud strategies. This can limit scalability, innovation, and cost optimization opportunities that public cloud services offer, and may not be the most pragmatic solution for all workloads. A third incorrect approach is to prioritize cost savings above all else, selecting the cheapest cloud services without considering their suitability for the application's performance, security, or compliance requirements. This can lead to performance issues, data breaches, and regulatory penalties, ultimately costing more in the long run. Professional reasoning. Professionals should approach cloud adoption by first establishing a clear understanding of the organization's business requirements, technical constraints, and regulatory landscape. This involves a comprehensive inventory of existing applications and data, followed by an analysis of their suitability for different cloud service and deployment models. A phased migration strategy, starting with less critical workloads, allows for learning and refinement. Continuous monitoring, security assessment, and cost management are crucial throughout the cloud lifecycle. When faced with rapid growth and pressure to innovate, it is essential to resist the temptation of hasty decisions and instead rely on a structured, risk-aware evaluation process that prioritizes long-term stability, security, and compliance. Question 20. What factors determine the most appropriate Oracle Cloud Infrastructure (OSI) region for deploying sensitive customer data, considering the need to comply with data residency laws and regulatory frameworks relevant to the Oracle Cloud Infrastructure 2023 Certified Architect Professional Syllabus? Option A. The OCI region with the broadest range of available OCI services and features. Option B. The OCI region offering the lowest network latency to end users globally. Option C. The lowest cost per compute hour and storage for the selected OCI services. Option D. The geographical location of the OCI region relative to applicable data residency laws and regulatory compliance requirements. The correct answer is D. The geographical location of the OCI region relative to applicable data residency laws and regulatory compliance requirements. Explanation. This scenario presents a professional challenge because it requires an architect to balance the technical requirements of a cloud migration with the stringent data residency and compliance obligations mandated by the Oracle Cloud Infrastructure 2023 Certified Architect Professional Syllabus, which implicitly aligns with common global regulatory expectations for cloud services. The architect must ensure that the chosen OCI region not only meets performance and cost objectives, but also adheres to specific legal and regulatory frameworks governing data handling and sovereignty. Failure to do so can lead to significant legal penalties, reputational damage, and loss of customer trust. The correct approach represents best professional practice because it prioritizes compliance with data residency laws and regulatory frameworks as a foundational requirement for selecting an OCI region. This aligns with the principle of compliance by design and ensures that the cloud architecture is built on a secure and legally sound foundation. By explicitly considering the geographic location of data storage and processing in relation to applicable regulations, e.g., GDPR, CCPA, or specific national data protection laws that would be relevant in a global context for OCI, the architect demonstrates a commitment to responsible cloud deployment. This proactive approach mitigates risks and builds a trustworthy system. An incorrect approach that solely focuses on cost optimization without regard for data residency fails to meet regulatory obligations. This is a significant ethical and regulatory failure, as it can lead to the unauthorized transfer or storage of data in jurisdictions where it is not legally permitted, violating data protection laws and potentially exposing the organization to fines and legal action. Another incorrect approach that prioritizes performance metrics like latency above all else, while ignoring data residency, also presents a regulatory failure. High latency might be a technical concern, but it does not supersede the legal requirement to keep data within specific geographical boundaries if mandated by law. This approach risks non-compliance by implicitly assuming data can be processed or stored anywhere to achieve optimal performance, which is often not the case under data sovereignty regulations. Finally, an approach that relies on generic security certifications without verifying specific data residency capabilities of the chosen OCI region is also flawed. While security certifications are important, they do not inherently guarantee compliance with data residency laws. An architect must actively confirm that the selected OCI region's operational policies and infrastructure support the required data localization, regardless of broader security accreditations. The professional decision-making process for similar situations should involve a hierarchical assessment. First, identify all applicable regulatory and legal requirements, particularly those related to data residency and sovereignty. Second, evaluate OCI regions based on their ability to meet these compliance mandates. Third, consider technical factors such as performance, availability, and integration capabilities. Finally, assess cost implications within the context of the compliant and technically sound options. This structured approach ensures that compliance is not an afterthought, but a primary driver of architectural decisions.